Hi, my name is Nathan Totten. Today I'm going to introduce you to Node.js on Windows Azure. We are going to begin by talking about Node.js and when Node is an appropriate choice for your application. We will finish by showing you how to build great apps with Windows Azure and Node.js. There will also be a few demos. Node.js is JavaScript that runs on the server. It is entirely event-driven and is not thread-based. Each connection to a Node.js server uses only a small heap allocation as opposed to consuming an entire thread as would occur on a traditional web server. These features make Node.js efficient and highly scalable. Node.js is an open source project that was started in 2009 by Ryan Dahl. It is sponsored by Joyent and continues to be actively maintained. Today, Node.js is one of the most popular projects on GitHub, with over 11,000 users watching the project. At the core of a Node.js application is the Node process. This process runs as Node.exe on Windows. Node runs the JavaScript V8 runtime. Your application runs on top of the Node process and the V8 runtime. Your app is composed of JavaScript you write yourself as well as third-party modules. Node.js runs as a single-threaded event loop. This thread must never block. Node.js applications are asynchronous by default. When a new request comes in, or an operation such as a database query is executed, the operation is added to the work queue. When the operations are completed, the callbacks are executed. This design makes asynchronous programming much simpler than many other languages because you don't have to worry about issues such as locking. Node.js is an excellent choice for building applications or components such as real-time communication, custom network services, web services, or web apps. Node is okay for forms-based apps, but often you will find that frameworks like Rails or ASP.NET are a better choice. Node.js is definitely not the right choice for CPU-intensive work such as video transcoding. Before we dive into Node, it is important to understand some of the pros and cons. One of the biggest positives about Node is that it allows you to write your application in JavaScript. Because many developers already know JavaScript, they can now use their existing skills to develop server-side apps in Node. Node also has a clean and consistent API and is very modular. Additionally, Node has a very simple concurrency model that can be managed by even low-skilled developers. One of the biggest benefits for using Node is that idle connections to your Node app are nearly free. Operations such as long polling are extremely efficient on Node. Some of the cons of using Node.js are that many important functions such as testing, validation, etc. are not standardized on Node. There are a lot of modules that will fill these needs, but the choice can often lead to confusion. Additionally, Node.js is fairly young and not widely adopted. Technically, Node isn't even a 1.0 release, so more conservative developers may not be enthusiastic about using it. Lastly, Node is pretty bare metal, and it certainly isn't meant for drag-and-drop developers. Node.js is extremely modular, and there are a lot of great community-built frameworks and tools to use. Some of the most popular frameworks are Connect, which is a standard middleware, Express, which does things like routing and templates, Getty, which is a full-stack MVC framework, and Josie, which is inspired by ASP.NET MVC. There are plenty more to choose from you can find on the Node.js website. When Node.js was initially released, it ran only on Linux. Several months ago, Microsoft began working with Joyent to port Node.js to Windows. Today, Node runs on Windows with performance equal to Linux. In addition to Node.exe, Microsoft built an IIS module for Node.js. This module allows you to host the Node process inside of IIS. There are several significant benefits gained by running Node in IIS. First, IIS Node automatically scales Node.exe to run on multiple processes. Additionally, you get access to logs over HTTP, you can run Node.js code alongside other code such as ASP.NET MVC, and you get an integrated management experience. This diagram shows how Node.js runs inside of IIS with the IIS Node module. IIS Node hosts multiple instances of node.exe to scale out to use multiple processors. You can see the configuration information needed to enable your app to use the IIS Node module. You can configure the module to handle all .js files, a single file such as app.js, or an extension such as .njs so that you can host client-side JavaScript in the same application. Node.js has an excellent package manager called Node Package Manager, or NPM. NPM is installed by default on Windows when you install Node.js. This package manager is similar to NuGet or Gems and allows you to easily install Node modules in your app using the command line. The command to install a Node package is npm install and then the package name. You can see some of the popular packages listed such as socket.io or Jade. There are several ways to install Node.js on Windows. The most basic is to download and run the Node installer from nodejs.org. Additionally, you can install Node, IIS Node, and other tools using Microsoft's Web Platform Installer. Web Platform Installer is nice because it manages dependencies for you and gives you all the downloads in a single place. You can get Web Platform Installer at microsoft.com/web. Now let's dive into some Node.js code. The first sample we are going to walk through is Hello World. The Node.js Hello World app is pretty simple. We have a single file called server.js that has these 5 lines of JavaScript to make up our entire Hello World application. Because Node.js has a built-in HTTP server, no additional modules or components are needed. To run our application, we simply call node.exe and pass server.js, our file name, as the first command argument. Note that I have added the Node.js folder to my path variable. This way I don't have to type the entire program files /nodejs /node.exe every time I want to use Node. With our Node app running, we can browse to our local host and view our Hello World application in the browser. Now that we've seen the basics of building a Node.js application, let's jump into something a little more exciting. In this demo, I will show you how to build a Node.js web app using the popular Express framework. To begin, we are going to use the command prompt to create our site and install some Node packages. First, I am going to create a directory for the project in node/nodeexp. Now, using Node Package Manager, I will install the Express framework. Express is a great web framework that handles common tasks such as routing and view templates. Next, I am going to run a Node script that is included in the Express framework. This script will generate my website's scaffolding and set up my app with a standard configuration. By default, Express uses the Jade templating engine, but you can use other templating engines such as EJS if you choose. After we run the Express script, we need to run Node Package Manager one more time. Calling npm install will install all of the additional dependencies such as Jade that are needed to run our project. We are now ready to run this default Express website. To run the site, we simply call node.exe with the argument of our site's entry point, in this case app.js. If this is the first time you have run Node on your computer, you may be prompted to enable node.exe through the firewall. Now I am going to open the browser and navigate to localhost on port 3000. As you can see, we have a simple Express website running in node.js. Now let's take a look at what makes up this website. You can see here the folder structure that was created when we ran the Express script earlier. You have the Node Modules folder, which contains the modules we installed with npm such as Express and Jade. Next, there are folders for static content, routes, and views. Finally, you see that we have an app.js file. This is our application's entry point. Opening that up with Sublime Text, you can see the code that makes up the core of our app. At the bottom here, you can see the routes. This line defines a single route at the root of our site and uses the index route to respond to the request. The route renders a Jade view called index.jade. Opening that up, we can see the clean Jade markup that renders to HTML. And that's it. We have a simple Node.js website using the Express framework. Now that you have seen how to build and run a Node.js application on Windows, I want to show you some of the great tools we have for Node.js and Windows Azure. Node.js applications on Windows Azure run in two ways. First is inside a web role with IS and IIS Node. The second way is inside of a worker role. When Node runs inside a worker role, a single instance of Node.exe is started as the role entry point. To make building Node.js applications for Windows Azure easy, we have created a set of PowerShell commandlets for Node.js Windows Azure development. Additionally, we have created the Windows Azure SDK for Node.js. The PowerShell commandlets can be installed using the Web Platform Installer, and the SDK can be installed using Node Package Manager. The full source code for the Node SDK and other Windows Azure SDKs are available on GitHub at github.com/Windows Azure. One important thing to note here is that you do not need Visual Studio to build, deploy, or manage Node.js applications on Windows Azure. All you need to develop and deploy your apps is a text editor of your choice, such as Notepad or Sublime Text, and the PowerShell commandlets. As mentioned, the easiest way to get started with Node.js Windows Azure development is to use the Web Platform Installer. Using Web Platform Installer, you can install Node.js, Node Package Manager, the Windows Azure emulators, and other tools in just a few clicks. As we showed earlier, the two types of virtual machines for running your Node.js application in Windows Azure are a web role and a worker role. The web role has IIS installed and uses IIS Node to host your application. You get the added benefits of process management, scalability on multiple cores, auto updates, access to logs over HTTP, and hosting side by side with other languages. Additionally, you get the integrated IIS management experience. The second type of virtual machine is called a worker role. This role hosts a raw Node.exe process and does not have IIS installed. There are a couple of reasons you would want to run Node.exe in a worker role instead of a web role. For example, running a scheduled task or a technology not compatible with IIS such as WebSockets are good reasons to use a worker role. Developing your Node.js Windows Azure application on Windows is extremely easy using a text editor of your choice and the Node.js PowerShell commandlets. Using the commandlets, you can create hosted services, add roles to your service, set configuration settings, launch your application using the local Windows Azure emulator, and deploy your application to Windows Azure. Here you can see the command to create a new Windows Azure Node.js application. The command new Azure service creates all the config files needed for a Windows Azure Node.js application. After we've created our hosted service, the next command is add Azure Node web role. This command adds the files needed to run a Node.js web role and updates the configuration files as appropriate. You can also create a worker role using the add Azure Node worker role command. Another useful command is start Azure emulator. As you might expect, this command starts and deploys your app to the Windows Azure emulator. You can also add the launch switch after the command to launch your application in your web browser after the emulator is started. These are just a few of the commands in the Windows Azure Node PowerShell commandlets that are available. You can read more by accessing the commandlets help or from the online documentation. The Windows Azure SDK for Node.js contains code for accessing Windows Azure Blob, Table, and Queue storage services. Support for additional Windows Azure services such as caching and Service Bus will be added in future releases. Installing the Windows Azure SDK for Node.js is easy using Node Package Manager. Simply type npm install Azure in the command line and it will be installed in your project. Here you can see some of the code for accessing blob storage using the Windows Azure SDK for Node.js. You can see how to create a blob, retrieve the blob, and delete a blob. Here you can see some examples of using table storage with Node.js. You can see how to insert an entity, query, and delete an entity. Finally, you can see here how to enqueue a message or get a message from a Windows Azure storage queue. Now that you have seen the tools available to develop a Node.js Windows Azure application, I will show you how to create a Node.js Windows Azure task list web app. To begin the sample, I'm going to open Windows Azure PowerShell for Node.js. First, I'm going to use the new Azure Service PowerShell commandlet to create the task list project. This commandlet adds the cloud configuration files needed for a Windows Azure Node project. Next, I'm going to add a Windows Azure Node.js web role to my project. To do this, I will call the Add Azure Node Web Role command. This command will add the scaffolding and files for a Node.js web role. Additionally, the command will configure my cloud configuration files with the new role. Inside of the web role directory, we use Node Package Manager to install Express, Node UUID, and the Windows Azure SDK for Node.js. After these modules are installed, we will run the Express script to create our Express web app. This script adds folders for views, routes, and the default app.js file for the Express framework. Next, we need to run Node Package Manager to install additional dependencies such as Jade. Now I'm going to copy the app.js file to server.js. Server.js is where the Windows Azure Node.js web role expects the application's entry point to be. We no longer need the app.js file, and it can be deleted if you would like. Now let's open the server.js file and configure the listening port. By default, Express is set up to listen on port 3000. We need to change that to run on the port that the Windows Azure web role provides to Node.js. To do this, we use the process.env.port variable. Now let's save that file and switch back to PowerShell. To test the site in the local Windows Azure emulator, we run the command start Azure emulator with the launch switch. This command creates the Windows Azure deployment package, starts the emulator, and deploys the package to the local emulator. The launch switch also causes our web browser to be launched when the application is finished deploying. And now we see that we have a default Express website. This is the same as the site we created in the previous sample, only this is running in the Windows Azure emulator using the IS Node module. Now that we have our basic site running, let's create a simple task list that uses table storage as the data store. First, I'm going to create a helper object called Home. We will create this in the home.js file. At the top of the file, we will set the required node modules that we will be using. For this object, we will use Azure and Node UUID. Next, I'm going to set the home object as our export and create the home object using the prototype pattern. The first method in our new object is showItems. This method will query table storage for tasks and render the home view that we will create shortly. You see here that querying a table with the Windows Azure SDK for Node.js is very simple. For this query, we will select all rows in the table called tasks. Next, we pass the query object into our query entities method along with the callback. The callback method simply renders the home view and passes in the view model that contains the page title and task list. The next method in our home object is called newItem. This method will handle the form post to create a new task. The incoming item from our form post can be found at rec.body.item. Item is determined from the form values we will set in our form view later. Next, we will set a few properties on this task item. The first is the row key, which will be a unique ID. The second property is the partition key, which will be set to all tasks. And finally, we will set the completed property to false. To insert this task into our table, we simply call the insertEntity method on the table client. The first argument is the table name, followed by the item to be inserted, and last is the callback. After the item is inserted, we will check for an error and throw if necessary, and then redirect back to the site root. Switching back to PowerShell, the next thing we need to do is create our home view. I'm going to paste some existing Jade markup in our home.jade view file to save time. The top of this view contains a table that displays each item in the task list. You can see how the Jade markup allows us to easily loop through the items and display the properties in table columns. On the bottom of this view is a form for creating a new task. You can see all the inputs that will get posted with this form. If you remember from before, we read this item object from the body in our new item method. You can see how we set those values in this form. Next, let's switch over to our server.js file. The first modification we need here is to import our home object and the node UUID module. Next, I'm going to create the table service and call createTableIfNotExists. This method will ensure that we have a table in storage called tasks. Finally, I'm going to bind our home object to a few routes. The first route is an HTTP GET at our site root. The second is an HTTP POST at \new item. Now we can switch back to the web browser and refresh the page. Because we never shut down our local emulator, our ISNode module detected file changes to our server.js file and rebuilt our site. Using our new Create Task form, I'm going to enter a new task and click Add Item. As you can see, the item was successfully created, we were redirected back to our site root, and the task was displayed. Opening up Cloud Storage Studio, we can see that the table called Tasks exists, and it has a single row containing the tasks we just made. Inserting another task, we can see that it is also created in the storage table. Switching over to Explorer, we can see our entire task list project. Our app.js file, if you remember, was created by the Express framework. We can delete that as it's no longer needed. Here you can see the views folder, which contains our home.jade file. And that's about it. As you can see, creating a simple task list with Node.js is quite easy using the Windows Azure SDK and the Express framework. You've seen several demos, an overview of Node.js, ISNode, and Node Package Manager. Additionally, you saw the Node.js Windows Azure tools and SDK that make developing Node.js applications for Windows Azure easy. Now you are ready to give Node.js and Windows Azure a try. Thanks for watching.